Hey guys, back at you with day 48. I just wanted to take a look at two quick problems here, 21 and 23. If you have any other questions from the review sheet, let me know in the comments today so I can do them in my video tomorrow. So anyways, day 21, when we take a look, it says above, or problem 21, above is the graph of f prime, the derivative of f on the interval 0 to 5. It says f prime has horizontal tangents at x equals 2 and x equals 3. Okay, so we have our kind of our classic f prime graph here. Try and figure out what's going on. So A says, on what intervals is f increasing? Justify. Well, your justification is your thought process to choosing the interval that you want here. F is always increasing when f prime is positive. Right? When we take a look, I see two places. I'm going to say f is increasing on 0, 2, union 2, 4. My justification is because that's where f prime is greater than 0. By the way, if you said 0 to 4, that's okay too. There's some debate in the mathematical community about whether or not f would actually be increasing at 2 or not. Speaking with graders on this, they're okay if you do it either way. Just be aware on a multiple choice, it might say 0 to 4. And that's okay. Just pick that one. Right? Still where f prime is positive. On what intervals is f decreasing? Well, f is going to be decreasing anytime f prime is negative. In this graph, f prime is negative from 4 to 5. So I'll report that. Because that's where f prime is less than 0. C says, what are the x values of the critical points of f, and determine each critical point, whether it's a local min, a local max, or neither. Okay. Critical points, we know by definition, is when f prime equals 0. So looking at our graph, we're looking for the zeros. I see a total of 2 zeros. I see one at x equals 2 and one at x equals 4. So let's start with x equals 2. Okay, that's a critical point. And that's a critical point that's neither a max or a min. Either because f prime didn't switch signs. How about at x equals 4, the other critical point? F prime definitely switches signs there. F prime switches from a positive to a negative, therefore that's a local max. X equals 4 is a local max. Part D wants the x values of the inflection points of f. Well, inflection points of f, right, we have to think back to our definitions. We know a few of them. The one that's going to be most helpful to us now relates to f prime, because that's the graph we have. Well, inflection points occur when f prime switches from increasing to decreasing or vice versa. So the 2 points that I'm going to identify are x equals 2 and x equals 3. Those are my 2 inflection points on this interval. My justification is, I always give the justification for the leftmost one and then do vice versa. So I say, you don't have to do that, but at x equals 2, f prime is going from decreasing to increasing. So I'm going to say that's where f prime goes from decreasing to increasing. Or vice versa. Because was at x equals 4, or sorry, at x equals 3, f prime switches from increasing to decreasing, right? Again, I'm always looking for those maxes and mins of f prime are going to end up being my inflection points of f, because those are the points where f prime is going to switch from increasing to decreasing or vice versa. Okay, let's take a look at problem 23 quickly, and we'll get you out of here. Problem 23, the first thing I want you to notice is it says the graph above is the graph of f double prime, right? It's an f double prime graph. So we're going to do everything differently than we did in the last problem. Okay. I can't tell when f is increasing or decreasing by looking at this thing, right? But all I can tell about is the concavity of f and inflection points of f. So those are the only types of questions that I asked you. Question A said, on what intervals is f concave up? Justify. Well, f is going to be concave up when f prime is increasing. That's what we use on an f prime graph. But this isn't an f prime graph, so don't do that. The other definition we know is f is concave up whenever f double prime is positive. So I just want to report the positive regions of this graph. The positive regions would be 0 to 2, union 4 to 6, union 6 to 8. And again, my justification is because that's where f double prime is greater than 0. And on your justifications, they don't need to be super long, right? They just need to be specific. We need to say f double prime is positive, right? It's got to be the correct definition, and it's got to be specific. Where would f be concave down? Well, that would obviously be from 2 to 4. Again, because that's where, that's where f double prime is less than 0. Inflection points then, right? We just talked about inflection points on problem 21. It was when f prime went from increasing to decreasing or vice versa. It's going to be totally different than that, right? Because we're not looking at an f prime graph. What I know about inflection points is that they occur when we switch concavities. Well, we switch concavities when f double prime changes signs. So I see two values where f double prime changes signs. I'm going to say x equals 2 and x equals 4, because that's where f double prime changes signs. I want you to be careful here. 6, x equals 6 is not an inflection point because we did not change concavity, right? Even though x equals 6 is a 0, and even though x equals 0 is a 0, right? We didn't change concavities, right? At 2, we went from concave up to concave down. At 4, we went from concave down to concave up. At 6, we went from concave up to concave up. So that's not an inflection point because we didn't change concavities. And since we don't know what's happening when x is negative, right, we can't assume that what's going on the other side of the y-axis. So that's it for today. Have a great one, guys. Again, if you have any particular questions you want answered, let me know and post them in the comments, and I'll try and get to them tomorrow. Have a great day at work tomorrow. 2 chains. Bye.